This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 6, Lesson 9, Corrosion and Chemical Processes. Corrosion is an electrochemical reaction. One metal, the anode, gives up electrons and dissolves. The other, the cathode, is protected, but only when the two are electrically connected in an electrolyte. Take away any one of those three and corrosion stops. The handbook ranks which metal loses two ways, the electrode potential table and the galvanic series, and names the 8 ways corrosion shows up. Prevention is just breaking the couple. Concept 1. The corrosion cell. Corrosion is a short-circuited battery you did not mean to build. It needs 3 things together: an anode, the active metal that gives up electrons and dissolves; a cathode, the noble metal that takes those electrons and is protected; and an electrolyte, the conductive solution that carries the ions between them. The 2 metals also have to be electrically connected, so electrons can flow. Remember which one is eaten. The anode corrodes. And notice the lever for prevention. Break any single leg of that cell, and it stops. Concept 2. The electrode potential ladder. The handbook tabulates standard electrode potentials: gold and platinum at the noble positive top, down through the reference hydrogen at 0, to magnesium and lithium at the active negative bottom. The rule that matters: in any pair, the metal lower on the ladder, the more negative, more active one, is the anode, and it corrodes. One caution on the sign convention: some specialties flip the plus and minus signs, so trust the direction, noble versus active, rather than the bare sign. Concept 3. The galvanic series. The electrode potential table is pure elements. Real parts are alloys, so the handbook also prints a galvanic series measured in seawater, from platinum and gold at the noble top, down to zinc and magnesium at the active bottom, with copper, brasses, and steel in between. Couple any two, and the one nearer the active end is the anode. Watch stainless steel. It reads noble while its protective oxide film holds, but slides toward active if that film breaks down, which is why it appears twice. Concept 4. The 8 types. The handbook names 8, and the exam asks you to match a description to the right one. Uniform eats the whole surface evenly. Galvanic is the 2 metal couple. Crevice hides in a gap where a concentration difference builds. Pitting is its localized cousin, drilling discrete little holes. Intergranular follows grain boundaries. Selective leaching pulls one element out of an alloy. Erosion corrosion combines chemical attack with mechanical abrasion from flow. And stress corrosion needs a tensile stress and a corrosive environment acting together. Either one alone will not do it. Concept 5. Prevention. And these methods are concepts to know. The handbook gives you the cell, the rankings, and the types, but it prints no prevention section. So carry these methods in your head. Every one of them breaks a leg of the corrosion cell. Coatings and paint keep the electrolyte off. Insulating washers cut the metal path in a dissimilar metal joint. Cathodic protection bolts on a more active metal, zinc or magnesium, as a sacrificial anode that corrodes in the part's place. Smart material selection keeps coupled metals close in the galvanic series and avoids a tiny anode feeding a huge cathode. And inhibitors or a passive oxide film slow the reaction. The one printed tool you lean on is the galvanic series. It tells you which metal is active enough to sacrifice. Setup. A carbon steel bracket is bolted to a copper fitting, and the whole assembly sits in seawater. 2 dissimilar metals, an electrical connection, and an electrolyte, so the corrosion cell is complete. We will decide which member is the anode and corrodes, then pick a way to protect it. The plan is to rank the 2 metals, name the anode, and then break a leg of the cell. Solve. Part 1. Name the anode. Copper is noble. Steel is active. The more active metal is the anode, so the steel bracket corrodes and the copper is protected. The galvanic series says the same thing. Steel sits well below copper toward the active end. And beware the area effect. A small steel fastener feeding a large copper cathode corrodes fastest. Solve. Part 2. Protect it and name the type. The couple itself is galvanic corrosion, type 2, 2 dissimilar metals in an electrolyte. To protect the steel, Use cathodic protection. Attach a metal more active than steel as a sacrificial anode. The galvanic series points to zinc or magnesium. That anode corrodes, and the steel becomes the protected cathode. It has to be more active than the part. Bolt on a nobler metal, and you would only speed the steel's corrosion. An insulating gasket or a barrier coating would also break the cell. Traps. 5 ways this bites. 1. The anode, the more active metal, is the one that corrodes. Read the wrong end, and you invert the answer. 2. The potential table signs can be flipped by convention, so trust noble versus active, not the raw sign. 3. A sacrificial anode must be more active than the part. A nobler metal makes things worse. 4. Corrosion needs all 3 legs, anode, cathode, and electrolyte in contact. Break any one to stop it. 5. Keep the mechanism straight. Crevice in a gap, pitting as discrete holes, and stress corrosion only when tensile stress and a corrosive environment act together. Quick recall. Corrosion needs an anode, a cathode, and an electrolyte in electrical contact. The anode, the more active, more negative metal, is the one that corrodes. The electrode potential table and the galvanic series both rank noble to active. In any couple, the active end loses. Know the 8 types by their mechanisms. And remember, prevention breaks a leg of the cell. Coat, isolate, add a sacrificial anode more active than the part, select compatible metals, or inhibit. Next up, Lesson 10, the Week 6 capstone. You can now trace how a material corrodes and how to stop it. The final lesson ties the whole week together. A rapid guide to naming any topic and reaching for the right section. Then 4 fresh exam-style problems spanning economics to corrosion. Everything's at peprepengine.com. Cheat sheet, worked solution, and a quiz attached here. If the course helps, subscribe.
The full study guide, with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.